radicals, and rational exponents. Our essential question is, how are exponents and radicals used to represent roots of real numbers? And here is our table of contents. Find all real nth roots. So an nth root of a number c is x, such that x to the nth power equals c. An nth root can be denoted by a radical symbol with an index of n. So the nth root c, where c is called the radicand. So again, this number that's out in front of the radical symbol is your index number. Whatever is underneath the radical symbol is called your radicand. And of course, you have your actual radical symbol. They can also be written as exponents in a fractional format. So you have equals to a to the 1 divided by nth power. What are all the real cube roots of 125? So cube roots, I'm asking for a radicand with a 3 in the index. So we can write it as the cube root of 125. I want to find the value of x when x to the third equals 125. So I can think about what 3 numbers that are the same multiply to get me 125. So it is an odd degree, so it has an odd number of real roots. An even degree, it has an even number of real roots. So we can remember that 5 to the third, or 5 times 5 times 5 equals 125. So one of my solutions is 5. We then need to consider if there's any other solutions. In this case, I'm going to realize that I can factor an x minus 5 out of this, and I have x squared plus 5x plus 25. Okay. X minus 5 equals 0. This gives us that solution of x equals 5. And we need to set x squared plus 5x plus 25 equal to 0 and solve that. We can find the discriminant of the equation when a equals 1, b equals 5, and c equals 25. So again, the discriminant is going to tell me if I have any other real roots. I can do that by finding negative b plus or minus the square root b squared minus 4ac. When I do that, I get negative 75. Okay, so that means the discriminant's negative, so there's no other real numbers. So the only solution I have right now is 5. What are all the real fourth roots of 16? So again, I can rewrite it as the fourth root of 16 with that 4 in the index. I need to find the value of x when x to the fourth equals 16. So I need to ask myself what 4 numbers multiply to get me 16. They have to be the same number. Okay, so I can set this expression equal to 0. So x to the fourth equals 16. So x to the fourth minus 16 equals 0. So I get x squared plus 4 times x squared minus 4 equals 0. The x squared minus 4 is the difference of perfect squares. So I get x squared plus 4, x plus 2, x minus 2. Okay. So I get x minus 2 and x plus 2 based off of these roots. And then the x squared plus 4 is going to give me an imaginary number. So the only real roots I have are x equals negative 2 and x equals 2. Understand irrational exponents. In the expression 16 to the 1/4 power. Okay, so to interpret the rational exponent, we need to look at the fraction. So I've got 1/4 as my fraction. It's my fractional exponent. Okay. The denominator of the fractional exponent becomes the index. The whole number becomes the radicand, and the numerator becomes the exponent that the radicand is raised to. Okay. So my denominator is 4. My numerator is 1. And my whole number is 16. So that means I have the fourth root of 16 raised to the first power. Okay. In this case, it equals 2, because 2 times 2 times 2 times 2 gives me 16. What is the meaning of the exponent in the expression 27 to the 2/3 power? Okay. So again, I'm going to look at my fraction. My denominator is 3. My numerator is 2, and my whole number is 27. So this becomes my index. 27 becomes my radicand, and I'm raising it to the second power. So I get the cube root of 27 squared. Okay. So I'm asking myself what three of the same number equal 27. In this case, 3 times 3 times 3 gives me 27. So I get 3 and then squared equals 9. Interpreting fractional exponents. So the index number becomes the denominator of the exponent in general. In addition, if m is an integer and m divided by n is in lowest terms, then I can get c to the m divided by n equals c to the 1/nth raised to the mth power, which equals the nth root of c to the mth power. And the nth root of c to the mth power equals c to the mth raised to the 1 over n, which equals c to the m over n. Evaluate expressions with rational exponents. Evaluate the expression 32 to the 3/5 power. So again, I'm going to use the same thing. My denominator is 5, my numerator is 3, my whole number is 32. So I can rewrite this as 32 to the 3/5 equals the 5th root of 32 to the third power. So I need to find 5 numbers that are the same numbers that multiply to get me 32. In this case, 2 times 2 times 2 times 2 times 2 gives me 32. To the third power is 8. How about 27 to the negative 2/3 power? So I do the same thing. Denominator is 3, numerator is negative 2, whole number is 27. So I'm going to have a cube root of 27 raised to the negative second power. Okay. I can then evaluate this. So 3 times 3 times 3 gives me 27. 23 to the negative second power, I can rewrite as 1 over 3 squared, which equals 1/9. Okay. And then 50th to the 3/4 power. So again, denominator is 4, numerator is 3, whole number is 50. So I get the 4th root of 50 to the third power. Now there are no whole numbers that multiply to get me 50. So I'm going to actually have to use a calculator for this because it's not a perfect 4th root. So using my calculator, I'm going to type in exactly how I have it done here. So I'm going to hit the 5, 0, the caret button, then the fraction button, 3, the arrow over, 4, and then enter. And that's going to give me approximately 18.8. You can also type it as a 4th root. Okay, there are ways to do that. You would actually need to hit the second and then the caret button, and that would actually give you the 4th root of something. But this is the way to do it with the fractional exponent. The Fujita scale rating F of a tornado is represented by F equals the cube root of W divided by 14.1 squared minus 2, where W is the estimated wind speed of the tornado in miles per hour. What is the Fujita scale rating of a tornado with an estimated wind speeds of 150 miles per hour? So I know my estimated wind speed is 150 miles per hour. If I look at my chart, I should get 2 when I solve this. Okay, it's an F2 rating. Okay, so I'm going to substitute 150 into W. Okay. And then I'm going to take 150 divided by 14.1. You can also rewrite this as 150 divided by 14.1 to the 2/3 power. So again, this is my numerator, this is my denominator for my fraction, and of course my radicand is my whole number. So I get 10.638 raised to this 2/3 power, which gives me approximately 4.837 minus 2. is going to give me 2.837. So you can see that it does correlate, and you've got this F2. So if the estimated wind speeds of 150 miles per hour is classified as an F2 according to the Fujita scale. Simplify nth roots. Okay, so I want to simplify the expression, the cube root of negative 8a cubed b to the 9th. Okay, first I want to determine the prime factorization of the radical. So I'm going to take everything underneath my radical symbol, so my radicand, and I'm going to break it into its smallest pieces. So negative 8 is negative 2 times negative 2 times negative 2. A to the third is 3 a's multiplied together, and b to the 9th is 3b or 9 b's multiplied together. The next thing I want to do is I want to create groups that are the size of the index. My index is 3, so I want to create groups of 3 that are the same. So I've got negative 2, I've got 3 of them. I have one set of 3 a's, and then I have 3 sets of 3 b's. These are going to actually come out of my radicand, and whatever would be left over would be what's inside my radical symbol and my new radicand. So I have one group of negative 2, I have one group of A, and 3 groups of B's. So that's going to give me negative 2 AB cubed. So when I'm simplifying this expression, the cube root of negative 8a cubed b to the 9th, I would get negative 2ab cubed. How about the fourth root of 256x to the 8th, y to the 20th? So I'm going to do the same thing. I'm going to determine the prime factorization of the radical. 256 is 2 times 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 2. Okay. I have 8 x's and 20 y's. So then I'm going to break these into groups that are the size of the index. In this case, I'm looking for groups that are size of 4. So I have 2 groups of 2's, 2 groups of x's, and 5 groups of y's. So that gives me 2 squared, x squared, y to the 5th. And of course, I can simplify x squared, which gives me 4. So my final answer would be 4x squared, y to the 5th. Use nth roots to solve equations. Simplify the expression 2x to the 5th equals 64. So when I'm solving this, I'm going to solve it like I would a normal equation. I'm going to divide both sides by 2, which gives me x to the 5th equals 32. And then I'm going to take the 5th root of 32. You can also write it as a fractional exponent. So again, 5th root, I get x to the 5th to the 1/5 equals 32 to the 1/5, which is going to give me x equals 2. Solving an equation in the form x to the nth equals c. So to solve an equation in the form x to the nth equals c, find the nth root of both sides by raising each expression to the 1 over nth power. You want to basically get this exponent by itself as much as possible. So you need to add, subtract, multiply, or divide in order to get the exponent by itself. Use nth roots to solve problems. One cube-shaped container has an edge length 2 centimeters longer than the edge length of the second cube. The volume of the larger cube is 729 centimeters cubed. When the larger cube empties into the smaller cube, how much water will spill? So I need to do a couple of things with this. I need to figure out what the volume is of my smaller cube. Okay. They told me that the one cube-shaped container has an edge length 2 centimeters longer than the edge of the second cube. Since the larger cube is bigger, that means that my smaller cube, x plus 2, is going to give me that 729. So I can set up the equation x plus 2 cubed, because again, it's a cube, so all the side lengths are going to be the same. Volume is length times width times height. In this case, it's a cube, so it's the side length raised to the 3rd power. So I'm taking x plus 2 cubed equals 729, since that's the volume of my larger cube. I'm going to take the cube root of both sides, 729. The cube root of 729 is 9, because 9 times 9 times 9 gives me 729. So then I have x plus 2 equals 9. I subtract 2 from both sides, so I get x equals 7. That tells me that my side length for my smaller cube is 7 centimeters. Okay, my larger cube is going to be 9 centimeters because 9 times 9 times 9 gives me that 729 cubic centimeters. Okay. Now I can figure out the volume of the smaller cube by taking 7 cubed. 7 cubed is 343 centimeters cubed. But I'm not done yet, right? They asked how much water will spill out of the cube. So I have 729 cubic centimeters in my largest cube and 343 cubic centimeters that this cube can hold in my smaller cube. So if I pour 729 cubic centimeters of water into a smaller cube, I'm going to have the 343 centimeters cubed fill up, but everything else is going to spill over. So I'm going to take 729 minus the 343, which is going to give me 386 cubic centimeters. So I will have 386 cubic centimeters left over that have spilled out of my smaller cube. Summary. So in conclusion, we've got our radical sign, we've got our index number, which is that number in between our radical symbol. We have our radicand, which is underneath our radical symbol. Okay. When I'm solving an equation in the form x to the nth equals c, I can either rewrite it as a power, or I can just take the nth, whatever the index is, that root to solve. I'm looking for numbers that match that index root to solve anything underneath in my radicand. Interpreting fractional exponents. So I have an nth root of a is equal to 1 over n. So again, my denominator is going to give me that index number. My whole number is going to give me that radical value, radicand value. And the numerator is going to tell me what I'm raising that radical to. And that is the end of Unit 5, Lesson 1.